Hello, Algebra students. Here's part 2 of Chapter 2, Section 9. So Section 2.9, Part 2, where we're going to talk about uniform motion or rate problems. All right, the first problem here, Nita took a non-stop flight to visit her grandmother. The 750-mile trip took her 3 hours and 45 minutes. Because of bad weather, her return trip took her 4 hours and 45 minutes. We're looking for her average speed for the round trip. Now, distance equals rate times time. That formula you need to commit to memory. Then you can manipulate this formula. We're looking for her average speed. Speed is the same thing as rate, so we divide both sides by t. And that's how they got total distance divided by total time. The difference here is just distance and time, but we're looking for total because we want to know her average speed for the whole trip, the round trip, down there and back. All right, so let's talk about her time. We had 3 hours and 45 minutes. I need to convert 45 minutes to hours so we can do miles. What was her miles per hour? So 45 minutes out of 60 minutes is going to give us 3.75 hours. That's her time going. And then it was 4:45 coming back. So that's going to be 475 hours, her return trip. Now what's her total distance? Well, it's a round trip. So she went 750 miles and she returned 750 miles. And her total time is going to be 375 going plus 475 returning. So we're looking for this total. When you punch that in your calculator, you get approximately 176.5, and I've rounded that to the nearest tenth, miles per hour. That is her average speed, miles per hour. Okay, let's look at the next one. In the morning, when the traffic is light, when the traffic's light, it takes 30 minutes to get to work. The trip is 15 miles through town. In the afternoon, there's an extra S there. In the afternoon, when traffic is a little heavier, it takes 45 minutes to go through town. What is the average speed for the round trip? So in the morning, when traffic is light, again, distance equals rate times time. We're looking for the average rate, so it's going to be distance divided by time. That's your formula. R equals, make that pretty, R equals distance divided by time. So we have 15 minutes through town, 15 miles. So our time, we're going to work and coming back from work, so our distance is 15 both ways. So we've got 30 miles round trip. So what's our time? 30 minutes is half an hour. Can y'all do that in your head? 30 divided by 60. And then 45 minutes, we did that in the last problem. That's 45 out of 60 is going to be 0.75. So we end up with 30 divided by 1.25, which gives us 24 miles per hour. That was their average speed going and coming to work. All right, moving on to number 5. 2 students left school at the same time, on their bicycle, and they're going at the same time. One's heading north and the other is heading south. The student heading north is going 15 miles per hour, and the one heading south is going 17 miles per hour. After about how many minutes will they be 7.5 miles apart? Now I know we said north and south, but for me I like to write this horizontally. There's the starting point. One went one way, one went the other, and the question is how many minutes? How long is it going to take them to be 7.5 miles apart? Now, they're traveling at different rates. So I tried to draw this in the middle, but truth be told, the student going 17 miles per hour is probably going to go a little bit farther than the student who is only going 15 miles per hour. So their distances are not necessarily equal. So I don't know what their distance is. Distance equals rate times time. So Time is what I'm looking for. I don't know how long, but the one heading north was only traveling at a rate of 15 miles per hour. The one heading south was at 17 miles per hour. So this distance, 15 times the time, plus the distance of the one heading south, 17 times time, and we want the total time to, the total distance to be 7.5 miles. So now let's make that into an equation. That'll be 15t plus 17t equals 7.5, and we're solving for t as in time. So 22t equals 7.5, divide by 22, and our time here is 0.34. So that's the same thing as saying 34% of an hour. What is 34% of 1 hour? That's going to be 0.34 times 60. So we were talking about 20.4 minutes. We have to convert here because they gave it to us miles per hour. So we have 0.34 of an hour. All right, so our last uniform motion example is number 6. It says that a railroad switching operator has discovered that 2 trains are heading towards each other on the same track. Oh no! Oh my! 2 trains heading towards each other on the same track. Oh me, oh my! Hurry, what are we going to do? Well, currently the trains are 53 miles apart. Okay, we've got some time. One train is traveling at 75 miles per hour and the other 40 miles per hour. The faster train will require 5 miles to stop safely, and the slower train requires 3 miles to stop safely. About how many minutes does the operator have, oh no, to warn the train engineers to stop their trains? Okay, so they're 53 miles apart. So this diagram is a little misleading. The whole distance apart that they are is 53. But don't forget, one train needs 5 miles to stop, and the other train needs 3 miles to stop. So we don't have all 53 miles. We have to take away the distance needed for stopping. So that leaves us here within the parameters 45 miles is what we really are working with. So we have 45 miles, and they have 2 different rates. One rate was they're traveling at 75 miles per hour, and we don't know how much time. The question is, what are we looking for? How many minutes do we have for them to stop? So if the first train that takes 5 miles to stop, let me read that again, the faster train, so the one traveling at 75 miles per hour, he is on this side because he takes 5 miles, plus the other train, which is traveling at 40 miles per hour, and he's going to need some time to figure out his distance. And together we have 45 miles because we had to subtract the 5 and the 3 that they need for stopping. So how much time do we have? Well, you total this up and solve for t. And again, we get a decimal. And it's 0.39. And we were doing miles per hour, so we have to now convert 0.39 into minutes because we were looking for how many minutes. So in an hour, there's 60 minutes, and we need 0.39 of an hour. So we need about 23.4 minutes in order for the trains to be able to safely stop. I hope that they're able to stop the trains, and I wish you all a good day and safe travels.